So, hello everyone, our respected professors in the meeting, my dear colleagues, participants, and one and all gathered here. Team GEO-AAKARSHAN welcomes you all to this webinar session. Thanks for joining us today. First, let me introduce myself. My name is Divyanshi Gupta, and I'm a student of MSc Tech Geophysics from Banaras Hindu University. And today, I'll be hosting the fifth webinar session of the GeoTalks lecture series of event GEO-AAKARSHAN, organized by SCG and SPG Student Chapter BHU. Along with me, we have Ms. Sakshi Sonkar as the co-host of this webinar. Today, we have our very wonderful guest, Professor Ramalingeswara Rao, sir. Before proceeding further, I would like to apprise about sir to you all. Sir has pursued his post-graduation in geophysics and PhD on earthquake risk from Andhra University, Visakhapatnam. Sir worked in various capacities as scientist from 1983 to 2010 in CSIR, National Geophysical Research Institute, Hyderabad. Sir has made significant contributions towards seismological studies in India, with a dream to make Indian infrastructure earthquake resistant. I would like to put before you all some of his contributions. Sir has prepared seismic hazard zonation map of India on various scales, which are of tremendous utility not only to the civil engineers but also to the general public in coping up with the earthquakes. Sir is the first to discover a new seismic zone in low to high grade transition zone covering the Andhra Pradesh, Karnataka, and Tamil Nadu states. Sir has prepared the first version of stress map of India by using earthquake focal mechanisms and is also the first to estimate core fluid diffusion rates and causative factor for occurrences of continuous earthquakes in Koyana-Varna region in the Maharashtra state. Sir has proposed a hypothesis on major earthquake occurrences in Himalayas and has prepared a much-needed, up-to-date catalogue of Indian earthquakes as a monograph from earliest 1200 AD to recent. Sir has also highlighted the importance of Buckingham Canal, which acted as a buffer preventing large-scale loss of lives during the Chennai tsunami 2004. Sir has requested the Government of India to revive the canal for tackling future tsunamis. Sir has till date published about 23 papers in reputed journals, which are of innovative type and widely referred by several authors for their research as well as referred in more than 20 books. I would like to apprise you all that Sir is nominated for Padma Shri Award and the Government of India has given the right to public to vote for him. So I request you all to nominate him for the Padma Shri Award. It is a great honor for us to have Sir today to deliver a lecture on the topic Doughnut Seismicity Pattern and New Seismic Hazard Zoning Map of India. I would like to inform all the participants that there will be a brief question and answer session at the end of the webinar, for which you have to type your questions into the chat box. We will also provide a feedback form so that we can improve our upcoming lectures. Please note that the form will contain 2 questions related to the talk. Participants who fill the form, only those will get the certificate. So do fill it. Also, for your prior information, the whole session is being recorded so that we can upload it to our YouTube channel. So now, I think we are good to proceed, and thus I welcome Sir to deliver his talk. Please, Sir.
Thank you very much. Good morning to all of you, my dear students. I'm very happy to be with you. Our Banaras University is my lovely university. I always have a great respect to the Banaras University, Department of Geophysics people, who loved me for the last 2.5 decades. For my research, they have been encouraging me, and some of them have encouraged me to do earthquake research in India. I'm one of them to propagate my ideas to the students researchers and civil engineers. My motto is to make Indian infrastructure at equal extent, which make this country prosperous and greenery for the future generations. That is my basic idea. With that, I have spent a lot of my lifetime for the CM earthquake research studies in India. Thank you. Shall I go to presentation?
Yes, sir, you can.
Yeah. Right. Yeah. This is my. Can you able to see my first slide?
Yes, sir, we can see the slide.
Is it visible to all? Okay. This I'm very much thankful to the students, SPG and SCG, who have invited me to deliver a talk on this definite seismicity of the Kelari earthquake. They asked me, and then I added new seismic hazard zoning map of India, which was published in my book. Also, I added to this lecture in the Seismic Activity Indian Scenario book by me. So, I am a retired scientist. My dear friends, students, clearly I will link everything. I will explain to the subject in a small way, not in extempore lecture. So, it is just like classroom. And next, here, earthquakes do occur due to faults, either normal fault, strike slip fault, or thrust fault. So these faults are hidden underground. It cannot be visible on the surface of the earth. So we don't know how to plan our city, how to decide to construct any structure, civil structure, heavy civil structure. We do not know. So unplanned city constructed over a strike slip fault. No. Our CSR have prepared an artistic view of this. Now, you see how the strike slip fault had slipped for a few meters due to a big earthquake, and all these buildings were collapsed because the city should not be constructed without proper understanding the fault mechanisms and existence of the faults in the surrounding city area. So this is the way which we are observing in the society. They are not observing the fault mechanisms, fault existing or not. Is it possible for the skyscrapers to construct all these things? They are not considering. So to bring the awareness to the people, we have selected this subject for your kind information. Next. See, the earthquakes are propagated. What is the meaning of earthquake? It's a series of motions transmitting from the source to all directions. The source is a fault at which a point or a plane in which all the earthquakes are being propagated, transmitting into all directions, and the damage of the buildings due to the, not because of the P and S waves, but because of the surface waves of low and private waves. You see, low waves are traveling along the surface of the ground. Low waves travel like a snake, just like a snake motion. The particle motions are in the horizontal way and propagating transverse to the horizontal line, and it is just like that. You can see this is the seismic love waves traveling on the surface of the ground. On the surface, which are there, some buildings which are there on the surface of the earth, you will see the tilting of the building like this, according to the motion of the love waves and surface waves of Rayleigh wave. Rayleigh wave is anticlinic particle motion, and it will also dangerous to the construction of the buildings here. So next, you can see here in the next slide picture, damage of the building partially and completely, because of the duration is more, the earthquake is very big one, the seismic surface waves and Rayleigh waves, just like Rayleigh and low waves, duration is more. The buildings will partially or completely collapse or raise to the ground because of the, based on that shaking of the building and collapse of the building, we can estimate the intensity of that earthquake at that site. So like that we are going to do here. Like here, another one is the in 1910. Before this, 1847, Mallet, who identified the definition he had given, earthquake motion of the seismic waves and propagating in all directions. Before that, he told that this earthquake was vaguely mentioned that after the rupture of the fall, after the crust rupture, the seismic waves will be generated. 2 to 8% of the seismic waves will be carrying energy and in propagating in all directions, and the rest of them are used for readjustment of the faults to elastic equilibrium. So here, the 1885 earthquake of New Zealand, which has shown, nobody knows a fault is visible on the surface, but 1885 New Zealand earthquake has shown the outcrop of that fault on the surface. Professor Henry Fielding Reid in 1910 is a professor of the university. He had come to an idea of elastic rebound theory. If you put a load on the scale and at one end and clamped in the other end, you will see the bending of the scale and finally break into two pieces. Just like that, that is in your lab. Here in the crust, it is assumed to be the crust is an elastic body, and gradually the load is being added and the deformation is being taken. The rods are being deformed and fences are shown displacement. So this had given him the elastic rebound theory. After the earthquake occurrence, this will be coming back to normalcy of elastic equilibrium. So when equilibrium when attained, the arc activity will be ceased. Just like Perry Bailey also mentioned that he had shown that by taking the arc sequences and put it in a cumulative strain release characteristic course and found that the compressional and shear stress, shear strains will be developed because of the readjustment of the earthquake crust fault at that time. So like that, so many researchers have given their ideas like this. So here, this is Benioff 1951, who told that one earthquake will give one strain curve like this. Here, presently 2001 Bhuj earthquake, Republic Day earthquake, have taken arcshaws and brought it like this. See, here we have seen two curves like compressional and shear compressional. This is another curve. That means the earthquake occurred because of the two earth faults due to the Bhuj earthquake. Based on the obstacles, we can see the things which are showing how many faults interacted with this. In other sense, you see this part of this indicating some fluid influence, creeping of this gradual creeping of this zone is known as a creeping of flow of the material. That means some material, some fluids might have acted as a grease, fault will rupture like that. So we can understand the physics of the process, physical process of the earthquake occurrences. Here, on the slide, I am showing you the same Binhoff model. I have taken strain release characteristic curves by taking about 40 offshore sequences all over the globe. I have taken and have prepared the strain release characteristics. And I found that the normal fault is just like this, and the fault mechanism will be there. And this strip directions will also be known. By taking the phi value, this equation gives you the slip angle also approximate, not because of this. So like that for a side slip fault, and this is for thrust fault or reverse fault like that. So I can show you in 3-in-1 here. These three faults of normal strike slip fault. This is normal fault, and this is the focal mechanism. This is a strike slip fault, which is having a motion horizontally. Is left lateral, right lateral. So this is the reverse fault and its mechanisms. It is, everything is known by observing the focal mechanisms of the area. So by the way, why should we know all the seismotectonics of the any region? Without knowing that, we cannot estimate anything. So presently, I have done a central Peninsula India, some earthquake recently, Bay of Bengal, had 1.5 magnitude earthquake occurred here. So extension of this, not 33, 34, one of the faults had gone to the Bay of Bengal, and culmination of 85, near to the 85 east ridge. There was a small change in the stress conditions. It had given 5 magnitude in the month of August 2021. So like that, whatever the earthquake occur in Peninsula India or in Himalayas, it is linked to the one of the faults. Number 1 or 2 faults may be the causative factor for the occurrence of the earthquake event. So this area is known as Central India. Some earthquake faults are there. It is showing the seismic activity was very much linked with the faults. You see, this is done by Russian team in NGRI. They found that the Hyderabad is here. It is Hyderabad is very recently developing city. Number of skyscrapers have come down. In this year, they told that 1500 million years ago, the upliftment of the crust has taken place, and all the small 2.5, 3 magnitudes are being. This is urban city, is known as urban seismicity, because if we cannot take care about the occurrence of this small earthquake and fault, the city will be in danger. So we should have some idea about this. Like that, we have to study any region in India. We must plan for the next generations should know the hazard of the areas. So next, see here, Gurgaon is the city south of Delhi region. Abhay Srivastava mentioned that it is a high risk place. Delhi region has 7 active and non-active fault lines. Unfortunately, almost of them pass either beneath or just adjacent to Gurgaon. It means that even a small tectonic shift in any of these fault lines is fatal for the Gurgaon people. So the city doesn't stand any chance of survival the quality of the building getting constructed today is taken into consideration. If you are not designed for properly the earthquake design, earthquake risk or earthquake ground motions are not taken into consideration for the multi-story buildings in the area, it is very dangerous. What he said, Abhay Srivastava told is maybe correct. Yes, the region had experienced two big earthquakes in 1720 in historical 7 magnitude and 1960 on the 6 magnitude. Like that, 5.6, 5.6, 5.7, half legend earthquakes occurred in and out Delhi region. People from Delhi region have been asking us why this is happening. This physical process we should understand, otherwise we cannot explain anything about that. But no spectral design ground motion DGM aspects have been considered for the construction of 1100 skyscrapers in the Gurugram region. The construction of skyscrapers in Hyderabad, Telangana state, and CRD AP need to be considered design ground motions of far and near fields. If the earthquake occurred in far off distance and the earthquake which are having 5 magnitude and 6 magnitude should also be considered the spectral accelerations, ground motions into consideration. How it will be possible, I will be explaining in future. So this, we must first of all understand the number of faults in India, how the seismicity is all along the Himalayas, and this is our flat boundaries, Himalayas and the subduction zone is taking place. This is oceanic subduction zone. This is continental subduction zone. This is Hindu Kush region, 4 road junction like that. All 4 plates converging at that place. Here, 3 tri-junction. One is in the inside, going inside like this. Another is going inside. Another from China, another clock. So this is a tri-junction where there maximum number of earthquakes will occur because of the strain accumulation. We can also from the our studies also we can understand. First of all, we must know how many faults are there. This is the GSA had published 2000 Atlas of the Seismotectonics of India. So next we can see here South Indian earthquake occurrences. Lithological units. Every lithological unit is having its own seismic activity. We should have an idea to understand the lithological cause. You see, this is a Bombay and other things. Historically, no number of earthquakes have occurred in this area. That is known annual flexure zone area. This is Western Dharwar Craton. This is Eastern Dharwar Craton. This is SGT. This part of this is known as SGT, Southern Granulate Terrain. So this is all lithologically Eastern Granulate Terrain. This is BKC. You see, BKC is free from earthquakes, mostly. Some earthquakes have come now. And Bastar Craton, no earthquakes. Some very, very after collection of number of earthquakes, 45,000 events for our country, India, we have seen that this is the picture. The distribution of earthquakes earliest to the 2013 for Peninsula India, especially. So magnitude 3 and above, I have taken unbroken cratons of Bastar and Bundelkhand, whereas Dharwar craton was broken. How? If I will tell in words, nobody believes it. So I plotted all the earthquakes in the map and found that a seismicity in the Bastar craton here and the Bundelkhand craton, in which Bundelkhand was also a little bit broken. See here, this is the Dharwar craton. Broken almost. A craton is just like a high strength material, thick crust material. It's just like idli, like that. So it was broken in Dharwar. Herein it is not unbroken. It is still little small earthquakes are still occurring, but no 3.5, 3 and above earthquakes are not being observed here for several decades, several centuries. So here it indicates the cratons are stable, high strength material, and no seismicity will be observed generally. But if it is observed, it is broken. It is active now. Thus, our NGRI and other people, 290, almost 97 years data have collected. Whether it is falling, these are all these are all lines indicating faults in this area. So all our geologists who worked for several hundreds of years, GSI and others, have given this. This is compilation of all the faults and compilation of all the earthquakes which have been plotted in a small peninsular Indian shield. See how it is linked, how big earthquakes are occurring along the fault lines. So we must understand, we must have the idea of tectonic bag and seismicity in our back of mind. Otherwise, we cannot understand things properly. So this is another aspect. I have collected 200 anorthides, alkaline bodies, and fusion bodies, and I plotted just like that. I plotted. It is showing this is just like a S-shaped mobile belt. All along the mobile belt, all these metamorphic intrusive bodies have been fallen in this. So what I got an idea that in those days, we don't, even today, we don't have number of GPS stations all in India. So I want to know what is the strain rates and what is the maximum observed magnitude and slip rates for at least for Peninsula India. I had tried. So I did for Southern Granulite and this Karpa Basin, Eastern Ghats, Godavari Graben, all these basalt strata, this NSL region and Aravalli region and this area. I have computed each and every part of the Deccan Craton with Koina, without Koina data. I have given the strain rates, the maximum observed intensity, maximum observed magnitudes, and slip rates from the observed earthquake data, strain accumulation, and I have computed the total strain rate and identify that how far it is possible. We can compare with the GPS data. So I was informed that the GPS data and these computed values are almost near to mirror to the observed GPS data. I'm very happy to know that. This is our Indian. Our India is facing every day 5 magnitude earthquakes or not. This is the concept. We have number of earthquakes per year and magnitude greater than 5. So we found that we are almost 69% of 59% of this Himalayas and this part of the continent is more active other than this. That means this is taking lot of time to develop number of any earthquake to occur in the area. So, for example, this is the Koina region is always showing every year 4.5 to 5 magnitude earthquakes because of the water, this force fluid diffusion rate increases due to the Koina reservoir. This earthquake will occur here. All along the plate boundaries, you see this purple colored boundary is a plate boundary area for India. How much beyond that we are lucky enough. We don't have every year 5 magnitude earthquake in India, but on and off we will get. Then next, this is actually 1897 is a peculiar earthquake which was that conjectural Doughty fault and this Oleham fault, which had given a maximum magnitude of 8 plus above in 1897. About this indicates that the fault is identified by Oldham, who in 1897, and it was just like showing how the Ceylon plate was uplifted. After this Doki fault, if you go to the area, you can all this area is abruptly down. The Burma, the download down of the land was down by few hundreds of meters. Why it is so? We did not understand. See here the seismicity of the area. Next. Here, what makes the earthquake occurrences in Peninsula India as well as in Himalayas? So there is a model of stress direction should be there. How the stress is propagated, because it is after the collision with the Eurasian plate, Indian plate, you hit by 65 million years ago with the Eurasian plate. The strain and all the stress directions must be there. Some pushing stresses must be there. Otherwise, how the plate moves. So, on surface of the earth of our Indian peninsula and as well as India as a whole, the stress direction, by considering the focal mechanisms, stress values of about 200, 300 observed data, I made a cartoon for this to brief understand, because the congested all the data will not give picture. So I made a cartoon for this and published in Tectonic Physics in 1992. It is they appreciated how the stress is taking diversion from the transition zone, low to high grade transition zone, and another place is Indo-Nagal zone. Stress is diverting from like this, along this. So it is, if you take the institute stress measurements, it is showing abruptly 70 degrees east, it has shown. All of a sudden, Hyderabad, 45 degrees east. Now, in some other place, if you go like that, 70 degrees. So here, this is the place where Indian plate is being bifurcated into and subjected into the Eurasian plate. In the eastern part, and western part has gone like that. So here you will get normal faults. So after hitting our Indian plate with the Eurasia, the back stresses will be developed in Peninsula India. So it may give some earthquake occurrences because of the back stresses to the Indian continental crust. How? You see, number of earthquakes occurred in low to high grade transition zone, where because of the shallow subduction zone has taken place in few billions of years back, and even today it is showing after putting bark an array of earthquakes observatories, they found that this number of earthquakes have been recovered by and plotted on this graph, and it was published in 1992, low to high grade transition zone of Peninsula India. This is known as Ramalingeswara seismic zone. Here, how earthquakes are occurring in different depths because of the rheology of the area. You see, the crust is divided into upper crust, middle crust, lower crust. The 30 kilometers can be divided into the 3 layers. If the crust depends upon the thermal structure. For example, if you know with the depth, temperature depth is there, you can generate Manglik and Singh and Singh from the HO. They have given equations for that, and they identify the rheology of the different crustal region at different places. They are not plotted like this, but when I have seen the S-wave type of mobile belt, I plotted their locations and found that the rheology of different crustal zones in different places are different. You see, from this, if there is no strength, the shear stress is there, shear stress versus depth. If there is no strength in between any zone, no earthquake will occur. If you are on the top of the crust, you will get upshocks also, earthquake and upshocks. Beyond, if you go down, you will not get aftershocks in the earthquake. Any earthquake occurrence in the lower part of the crust, you don't get aftershocks because of this stress, zero stress existence in the rheology of the crust. Here, now, before understanding the definite seismicity of any region, how the earth is behaving, earth is giving signals to us before the occurrence of an earthquake. In any earthquake of 6 magnitude, we will find some reasons here. 2 years before the occurrence of Jabalpur earthquake of 1997, May 22nd, earthquake occurred. Number of swarms occurred, have been observed in the in and around the Jabalpur area. Before earthquake, you see Gwalior, Talcher, Pandwana, Khandwa, Ratlam, and Chindwara. All these things have experienced a swarm type of small earthquakes. A swarm is a small equal magnitude earthquakes without any main earthquake. So major earthquake in that. So that swarm is indicating anything for the future earthquake or not. We have to know. We have to know. So what I did is I observed and found that there was at 23 kilometers or 30 kilometers of that focal depth area. I computed the pore fluid pressure, existence of the pore fluid pressure on the Narmada. It was falling on near the Narmada zone bed. It happens to be a presence of serpentinite, which had given rise to pore fluid pressures of 880 megapascals. That force of that much of the pore fluids being pumped into the other parts of the areas where there is weak zones, it had gone that place and created swarms like this. So next, this is one of the observations. Here, Koina 1967 earthquake occurred, 6.3 magnitude earthquake occurred in December 10. Before that, you see, if you observe, I have gone to this place, Mahan, it is 1.2 kilometers, very hillock area, the hill area, Western Ghats. Here, before earthquake occurrence, this earthquake had occurred, and another 2, it has come just before that. So here, 2, like that, 3, 4. These 4 earthquakes occurred just before the 6.3 magnitude of 1967 December earthquake. So that means it indicates some phenomena. This is the observation I made during DST's request. I have 3 shocks observed like that. So next. Now here the hinge zone. Hinge zone is running across all along the Kolkata region, and eastern part of hinge zone, it is going to up to Shillong area. 1897 earthquake occurred there. So here, number of earthquakes occurred during this 1737 earthquake. It is doubtful. Afterwards, so many minor earthquakes of 4.5 magnitude earthquake, and stopped suddenly. So, but people are constructing multi-story building because they thought that it is a safe zone. And several people have been asking me why these people are constructing on the sediments, marine sediments, which are very dangerous and not possible to withstand for a major earthquake. So they have been asking me, and we should take care for the necessary action should be done by the Bureau of Indian Standards, not personal researcher. So this is Delhi region. People have been asking me why it is coming. Several people telephoning me and asking me that the small microtremors have been occurring because of the transverse faults with cutting across the Himalayas, where there is small changes in the Himalayan strain zones. It will give small earthquakes here. Jajjar and Rohtak and all other regions are affected with this Sohana fault, and all these things are continuously giving us 2.5 to 4 magnitude, and people are frightened. And it was a pathetic condition that everybody is using, constructing multi-story buildings, skyscrapers, without taking a proper design ground motion, DGM parameters. But nobody has prepared also. I have prepared. I will show you all these things in future slides. Next slide. Here, another good observation I made. You see, this strain budget. This indicates the strain budget. You see the Himalayan subduction zone. This zone is affected with 7.7 magnitude and above. See, these red stars are represented here. This is known as North Indian Plate boundary. All these red lines are occurrences of 7.7 magnitude earthquakes, and these are the epicentral locations of 6 magnitude and above in Peninsula India. You see the logic here. Here, 22 years, all these Himalayan belt are affected with 7.7 magnitude. 4 to 5 events of 7.7 will occur along the Himalayas. There will not be any earthquake here. If you plot, you see there will not be any earthquake in Peninsula India. This is South Indian Shield area, SIS. So you black line down is indicate there are no black line down. And it stopped. After 22 years period, it was stopped. No earthquake of 7.7 occurred in Himalaya, Peninsula in India started occurring 6 magnitude and above. See, this indicates that the strain which is developed in Peninsula India is being transmitted slowly to the Himalayas, or the back stresses will be affecting the Peninsula India. We don't know. But the action of this hypothesis, I found that during the observation of the data set, I found this is the thing. Here, another cycle started, and 1900 earthquake had occurred, only one. But 4 or 5 earthquakes occurred here. Like that, here another peculiarity here. This cycle should be 22 years it should be there. But here, all of a sudden, 44 years, the gap is there. 22, 20, 44 years. So we got 6 magnitudes in Peninsula India. Now, again, Himalayas are showing active. Only 3 have come. 2 more are sending. 2 more are impending earthquakes of 7.7 may occur in Himalayas. We are expecting from this because of the old records. Here, we are suspecting the earthquake occurrence in Kashmir in this area, 76, 75 years, and here in because of the junction of the 90 Ridge, the maybe big earthquake may occur in these 2 areas. We are expecting, with the experience of continuous observation of the earthquakes. Next slide. See, now we have come to the Doughnut seismicity of Killarney region. Our interest of here, why Doughnut seismicity have been observed before occurrence of the Killarney earthquake. Killarney earthquake is falling in Craton, Dharwar Craton. The Arar Craton was broken with a small fault of Killarney region. That on 30th September 1993, one earthquake of 6 magnitude, 6.2 magnitude occurred here. So, because of the 3 fault, activation of the 3 faults, this is reverse fault, this normal fault, and strikely fault. Occurrence of this, before this occurrence of this 93 fault, before 93, we got like this. And it has shown before the occurrence of Killarney, tremors with sounds have been observed. Asholikar had given a report to the government of Maharashtra, showing that the sounds are being reported by the local people, and they recorded and submitted a report like that. Like that, geologists, geophysicists, others have gathered the area, gathered the source information, and plotted. We have plotted this. Doughnut is a district like this. In this, number of earthquakes have occurred just before this stellar earthquake. This is known as this part actually 1974. GEO-AAKARSHAN identified this Doughnut seismicity before the major earthquake in subduction zones or in some places, the major earthquake. But here also we can find the Doughnut seismicity. Of course, it is not full-fledged. This area was covered with the zones because of paucity of the data or because of the non-reports. We cannot plot all these things. Whatever is there reported in the literature, we have plotted like this. We got like so. 1974 the Mogi did. We followed the same procedure and found that before the background seismicity is there and sounds of the small tremors and sequence of tremors are there. Just before the main shock, we got this earthquake sequence here near to the epicenter location. So this is 2, and this is after 3, after 2, the Salimba, just before the Kelari earthquake, Salimba was very active and shown number of sounds and earthquakes, tremors have occurred here. After that, 1930, the earthquake, Kelari earthquake, September 30, 19.6.3 earthquake had occurred. See, this sequence is known as Doughnut seismicity pattern. Next, we are going to the next phase of this presentation is, first, several people have prepared seismic zones. Before, first of all, our Sundarlal S.L. Kumar, 1931-30. He was an engineer, civil engineer. He was assigned some task of construction of the buildings in the area. He found that it must be earthquake resistant because near Quetta is there. He was appointed in some place, remote place near to the Quetta region. He constructed by using the unused railway pattas. And he made use of those iron rods into the slab and plinth levels he prepared and constructed the colony for the railway employees in that area. 1934, 35, 2 big earthquakes occurred. But this colony was not affected because of the design portion, design of the structures resisting the earthquake without falling, they are sustained there. All other buildings are raised to the ground. Then he is the first person who made a seismic zoning map of that area. So afterwards, people thought that this zoning is an important parameter to know and to assist the earthquake occurrences in Peninsula, in the RNA, Himalayas. Of course, the population of the density population is very less. Even then, they made, and you see, based on the isoseismic maps prepared by the GSI during big earthquakes which occurred in Peninsula India or as well as in the Himalayas, they reported in their report. They have reported in GSI. They have a number of reports are there. Based on that, in 1957. W.D. West prepared a seismic zoning map of India. Like that, several zoning maps are there, but based on the seismals, he made like this. You saw high stress, high dangerous, low dangerous, and islets of the most dangerous zones was found by him. So here, I did my work in 1979 and got my PhD. I submitted my PhD in this Lomlitz methodology. I was used to identify the risk value. Hazard zone was prepared. See, why I am showing here, even in 1979 work was being reflected with the UBS data. This where is the high stress zone is the high strain accumulation is there. This was implementing this is indicating that high hazardous zone area. Here also, you see, Roger Bellamy in England, they found that the high strain, because of the accumulation of high strain accumulated in that area, it will make you rise to 8.6 magnitude. See the risk, and this GPS data indicating not deviating anything. You see here in Rajasthan, here in northwest Kashmir region and northeast India, and along this Andaman Nicobar Islands and the eastern part of that. This Burmese South region. See, Indian country, this is only one. The meager data we have computed the earthquake risk map of India. Now, I have taken 10,000 isoseismic modified Markov intensity scale data of 36 isoseismic maps, digitized and plotted by using the GeoSoft. We got like this. This indicates that the seismic waves which have given rise to the accelerated because of the soil conditions existing at the place. See how the dangerous parts are there because of 1934 North Nepal Bihar earthquake and Assam 1897 earthquake. They have shown a lot of this area, this tract was completely demolished and the whole structures was uprooted in both the 1897 earthquake as well as 1950 and 1934 and Congo region like that. See, we must care that the local soil conditions and as well as the ground motion values. So we must make use these ideas into our next future generations should be developed. Resilient buildings. Resilient buildings means earthquake resistant buildings should be there. Otherwise, we'll be in danger. So, what to do? So, here, what I have done is, I have done a scale of intensity. I have collected 45,000 earthquakes intensities as well as magnitude, moment magnitudes. A list of all these things are prepared and put it on a scale of this. See, this is a moment magnitude scale, this is intensity MSK scale, and this is zone factors, division of the zone factors in the area. Because of S.L. Kumar, we have no idea to categorize zones according to the observed seismic accelerations in the area affected because of the intensity. We can convert into the accelerations. We don't have accelerometers throughout country. Very, very mega, very, very few. So we can't establish the empirical equations given by several people in India and myself. We made a category of this zoning factor based on this equation. We made a zone factor. Zone factor is a effective zone. We should have a zone factor for this introduced 2002 map. They introduced a zone factor like this. In between all the zone factors are based on prepared on zone 1, zone 2, zone 3, zone 4, zone 5. So based on this zone factor and all these things, new seismic hazard zoning map of India generated by combination of 45,000 MSK intensities and seismic hazards estimated by NDMA and Iyengar 2011 for 9,500 grid points of entire India as zero period acceleration contours are plotted on the map with the observed seismic intensity zoning map and with the zone factors is showing they are both of them are following the same trend. Very, very few places it is deviating, but everything is following. So with that we can understand this is the actual observed seismic zoning map of India. If you want to give probabilistically high value, the builder cannot assess the actual factor of design coefficient. If you increase, abruptly change, double the value of that site area, high seismic coefficient, the construction cost will increase. So we should give the actual value, and he can identify the necessity for the increase of the zone factor into that. Next. So here the maximum response of the group structures. If you put the accelerometers on different heights of the structures, you will get the spectrum like this. You see, the spectral accelerations are being plotted like this. If you are having a short period, 2-3 floors on which you put an accelerometer, the seismic accelerogram will be like this. The maximum recorded amplitude is being plotted here. Is being plotted here. So, like that, a number of buildings showing some maximum peak values. That peak value will be plotted like this. So, every maximum value is plotted like this. So you will get maximum response spectrum. The contour which is touching the y-axis is a zero period angle, because the time period is 0 here. Here 0, 0, 0.1, 0.2, 0.1 second, like that. This is the time versus acceleration, spectral acceleration. So at 0 point, if the line is touching, this is known as zero period acceleration. The zero period acceleration, half of it, 2 times the zero period acceleration is zone factor. So in the map we have shown zone factor. Zone factor depends upon the zero period accelerations of any region. Due to any small earthquake or big earthquake or far off earthquake or near earthquake, the spectral response curves must be there for each and every structure. We must take care, otherwise the multi-story buildings will be in danger. What Abhay Srivastava told. You see, this is we have prepared elastic response spectrum for Indian standard type 2 medium soil for 5% damping for zones 3 and 4 and 5. After Subramanian and Velayutham, they have very categorically shown that the response spectrum of each zone, how it is behaving. You see, zero period acceleration for zone 3 here. That means 0.24. 0.24, below that 0.1. This is 0.16 for zone 3. This is zone 4. 0.24. It cut at 0.24. And here another like that, these values 0.3, it cut at zero period acceleration at this. See, acceleration response spectrum is itself is indicating the zone factors like that. It is, we cannot deny the observed values. If you want to construct in the zone 3 side, you can enhance the value of zone 4. But if you are giving a high value, he cannot come down to the zone 3. He cannot take decision. If that map should be observed data must be as it is. If you construct a multi-story building, you can take based on this period as well as the spectral values like this. It is highly useful for the civil engineers. Now, you see, you observe this, how a structure, because of the earthquake occurrence, how the structure will respond to at what frequency, at what period it will react. Is one-story building is 0.1 second. Another reinforced structure at 0.180 and 0.2. And if you construct a dam, see I have given Tehri Dam design coefficient at what period 0.35. So this is the risk value we will estimate before the construction of the structures. Then the dam will be shaped. Like the 3-story building, 0.7. Like that 36-story building, steel building, in just like American trade centers like that. These buildings are being designed for this period because the earthquake natural frequency should not be equal to the natural frequency of this structure. If this is same, those two things are same, it collapses. The building will collapse. Like that, this is 60-story building. How many? 3 seconds. If you want to construct 60 seconds, 3 seconds must be. At that site, we don't know how much what is the type of soil at that place you construct. Also should be constructed. But this is the natural period of this structure. This is the natural period of the 60-floor steel building is 3 seconds. So like that, if the grounds at that place having the natural period of 3 seconds, this will collapse, will be in a danger. That is, that should be very careful, we should take into consideration. And 250 meters high, nowadays they are constructing enormous heights. So you see 4 seconds of this building is having, if you construct 250 meters high, the 4 seconds, its natural period is 4 seconds. The ground motion should not be having a natural period of the ground motion should not be equal to the 4 seconds. You see, this happened during Mexico earthquake of 1985, which 300 kilometers. The earthquake was 300 kilometers away from the Mexico City, but all the multi-story buildings skyscrapers fallen because the seismic waves which have entered into the lake sediments, which are having multiple amplification of 50 times, more than 50 times, and it attained to the 4 intensity. Yeah. 4 more equal to the natural frequency of the 60 floors, 250 meters high buildings were collapsed because of the high 550 times amplified, and it had fallen. So these small buildings of about one floor, 2 floors are not affected much, but the multi-story buildings up to 50 meters affected because of the natural period of the building, 4 seconds, and the output of the ground motion from ground is also 4 seconds. So the total collapse of the buildings has taken place during the Mexico earthquake. So I'm very much unhappy. Our Indians builders and others, they are constructing based on this type of thinking or not, I don't know. But we should be taking, we should take in future with the maximum precautions by considering the lower basement structures, if it is lake sediments or river beds or in the ridge places. We should be careful to identify the bridges, for example, bridges, 1300 bridges. Nowadays, non-supporting wiring bridges are there. What type of frequency it will be? 10 seconds. So 10 seconds of the natural frequency of the ground should not be there. That is the main cause for this reason. We should have a map of how to generate the response spectrum for the nuclear corners of the India. I made throughout India a number of places we can study like this. See, here I am using the GeoSoft, whatever the data which was published by, given by Professor Narayan Iyengar, who had supported me in doing this. They have given me data. I plotted number of zero period acceleration. One map, the first map is zero period acceleration. Anywhere in this place you can pick up this place or this place or this place. You can pick up that site and put it here, that value. If you are going to 0.2 seconds map, if you pick up that same place and put it here, and like that, 1 second map, this is 1 second map, and you same place you can go and pick up the value and put it here. So you'll get the spectral response spectrum of the basic crust. Afterwards, 30 meters soil is there, you have to compute, and add to this place, add to this, and it may give you the design ground motion parameters for the construction of any building in the area. For near shock earthquake or near shock of 7 magnitude or far off shock of 8.3 magnitude, we have to design and construct the multi-story buildings or skyscrapers in future. So this is my ambition to, the people are not, these maps are not published by anybody, but this is the procedure I have adopted, and get the basic concept of elastic period, zero period accelerations, and this response spectrum at any place of India. I made it for the civil engineers. Here, we have taken a model like this, how to generate peak ground accelerations due to a small identified fault for 5 magnitude, 5.5 magnitude at different zones. For example, Pondicherry, we have taken the small, this is the mathematically generated the seismic accelerometers, the spectral acceleration as well as the 5% damping. Chennai, and for the Ongole region, we have done how the response spectrum will be generated mathematically also. This we can, you see bedrock, how if accelerations are, if your accelerogram is on bedrock area, it will record the earthquake accelerations here. And this is soft mud, it will accelerate like this. If it is in sand and gravel, it will be like this. So with these understanding, we can go for this one. My book was launched by Vice President, now President of India, Sri Venkaiah Naidu Garu, and on 2015 November 6th at PM. This is my web link is there for book info. By taking this into consideration, if you want, you can go to that. This is Venkaiah Naidu Garu had released with my approach and with my book on that day. I'm very happy. I'm very much thankful to Honorable Vice President of India, Venkaiah Naidu Garu. This is the map I want to propose for the VAS to implement for the future generations, to implement for 6 floors, and that spectral acceleration maps also for skyscrapers will be. These maps are available in my book. Thank you very much for this. Thank you very much, all the students. If any questions are there, you can ask me. Nana?
Thank you, sir. So we are very grateful to you for delivering such an informative and engrossing lecture. I would like to remind all the participants.
Yeah, you can ask any questions. Arish Babu?
Yes, I request the participants to put forward their queries.
Is it audible and clearly known to you?
Yes, sir.
You can understand what I am telling.
Yes, sir.
Yeah. Any questions are there?
So we have some questions in the chat box.
Anybody can ask any question.
So the first question is from Mr. Amrendra Pratap Bind. The question is, what is the return period?
What is return period?
Yes, sir.
Any region, number of earthquakes will occur. You see, the log n is equal to A minus Bm, identified by Richter. First, Richter identified this equation for empirical relation. From that, he found that each magnitude of earthquake is having its own return period. For example, 5 magnitude earthquake, any region of a small 100 kilometers by 100 kilometers area, which you take, that is the source region due to faults, you can estimate log n is equal to number of earthquakes, and A and B are constants, M is the magnitude. This relation we can estimate the 1 by T is equal to frequency. The frequency of the earthquake of such magnitude will be known to you from the Richter equation. That is written. Period of 5 magnitude, if you want, how many years it will come. For how many years the same magnitude, approximately plus minus 1 year, how many years. According to the seismic activity of the area will be known to you. Okay. Okay, na?
Okay,
Next.
sir.
Okay.
So the next question is from Mr. Deepak Kumar Bharti. The question is, which parameters we have to consider to decide seismic zone such that it is high or low?
Then, which parameter?
So it is written over there that which parameters we have to consider while deciding the seismic zones.
It is not clear to me.
I request Mr. Deepak Kumar Bharti, sir, to please reframe his question.
He can give me in writing somewhere. I am not able to understand. I am not able to catch his question.
Okay, sir. I request Deepak, sir, to please reframe his question.
Which parameter?
Sir, he is asking that which parameters we have to consider while deciding seismic zones, that they are high or low. Seismic zones are high or low.
Seismic zone, what parameter we have to consider? That is the question. So
Yes.
It is correct. High seismicity zones parameter will be 5. If you are in zone 5, the parameter will be 0 period acceleration will be more. So we have to consider how much the accelerations will be affected this area within the 50 years vision period. Any structure you construct in 50 years period, this type of magnitude 8 or 7.5 and above will hit the structure or not. So the zone factor is a bearing factor for the zone. For example, zone 4. You are say for example, Delhi is in zone 4. So we must think that the zone parameter is 0.2624. That parameter we should be considering for the construction of the building.
Okay, sir. So the next question is from Mr. Lakshmaya Bhathulla. The question is, what is seismic gap region and how to predict the occurrence of earthquakes in this region?
Seismic gap.
Yes, sir. Seismic gap.
Seismic gap is a place in which the strain may be developed along the fault zone or anywhere. There should not be any earthquake for a long period of about hundreds, thousands of years. If it is not there, that will become a seismic gap. All along the other places, earthquakes will be active, but this not, because the area which is having a high strength material to resist the strain stored in that area. For example, Nepal Himalayas we have seen in the photos in my PhD work. There is a lot of strain accumulation in that area, but it is not giving very frequent earthquakes. There is a small seismic gap in the zone, Himalayas zone, where the strain accumulation has taken a lot of time. Accumulation has taken a lot of years, so many years back, and still it is not showing any earthquake. So it may be dangerous in future. The seismic gap is the dangerous part to know for the impending earthquake in future. That is the seismic gap.
Okay, sir. So the next question is from Mr. Vishal Kanodia. The question is, what is spectral design ground motion?
Yeah.
Is it a type of precursor?
Spectral acceleration, you see, if you are establish a number of accelerometers and the ground, any earthquake of 6 or 7 magnitude occur in the nearby area, all the ground motion is ground is same, but earthquake is also same. The different at different location, different soil characteristics will show you different accelerometers values. If you are having you see in any area number three floor building, 4 floor building, 6 floor building, 24 buildings are there. If you put all accelerations, you will get the time periods are different, as I shown you in the figure. So we must take all the accelegrams and make it a spectral acceleration, plot it on a time versus spectral acceleration graph. We will find the a cap-like structure will be observed in. I made 3 maps: 0 period acceleration and 0.2 seconds and 1 second. If you know these values, you can draw the cap of that spectral design map for that area for basement structure. Not the 30 meters of soil have not considered, because I don't know if you are in the basement, river basin, or in the some other basins or some other ridges you are there. So I can't predict, any place. So where it is basement structure, ground basement, up to that I have made it. So the spectral acceleration is useful for the construction of multi-story buildings, to know the period at which the natural period of the ground will be known. So you can estimate the natural period of the multi-story buildings. How many floors I have to take? This area is having this much of the natural period. Ground is having natural period of this much. So how much I have to consider in the building design? That will be known. No? If you know the ground structural natural period, you can understand it should not be the same natural period should be there for the building. If it is equal, the building will collapse. That's why we must know the natural period of that ground at that site. That is the use of these maps.
Okay, sir. So the next question is from Mr. Srinivasan Rajagopal. The question is, active fault mapping of the country and southern peninsula has not been taken up in detail. What are its impact in hazard donation made?
Can you repeat me again? Because it's not audible to me.
So the question is, active fault mapping of the country and southern peninsula has not been taken up in detail. So what are its impact in hazard donation?
So I'm having some hearing problem. If you don't mind, you send me any. Can you tell me in a small, short manner, small, or you can write?
So he's asking that since active fault mapping of the country and southern peninsula has not been taken up in detail, so can it impact the hazard donation?
I'm sorry, I can't answer. Because I don't, it's not audible and I'm not able to understand what you asked. Can
I speak to you for a minute?
Who is that?
Sir, I am a retired Deputy Director General of Geological Survey of India, Srinivasan.
Geological Survey of India. Rajgopal?
Srinivasan.
Srinivasan.
Sir, namaskar, sir. Very good lecture. Good, very brief and very nice way you put the basic facts to all, particularly to academic community. But the basic lacuna which all can understand, the faults which are to be classified, whether it is active or what is the status of the existing fault. See, then only our hazard zonation or site-specific any seismic hazard will be more relevant, sir. Otherwise, many faults are taken into consideration which are not active at all. So, what is really the country's active fault mapping to be given a thrust? Will you agree?
At the moment, I can't answer you. But
Because Geological Survey of India, sir, GSA in its program takes up active fault mapping, but only in the Himalayan region a small way. But for the whole country, for for a good seismological study, the basic fundamental is the active fault mapping to be taken out and all the known faults to be classified whether they are active or dormant or they are dead.
You are 100% correct.
This is very important critical factor.
You are correct. Government has to take up seriously the projects of the different seismic hard analysis should be known each and every corner. You see, for example, the microgenation studies have been started in number of cities only. So throughout country, it is not the government has not taken seriously. If you know the microgenation of whole country, America, they have, you see, recently you know that bill was prepared by senators of USA. So what they did, infrastructure bill, that is known as infrastructure bill, means there should be resistance power to be given to the structure by implementing the codes. Code is God. God will save us. You know, that's why government is not taking at all any seriousness in that. Unless if any earthquake of magnitude 8 or 7 earthquake occurred in India, hundreds, thousands of people will be dying. In other countries, it is not possible because 1 or 2 people die. Why? They have taken a lot of infrastructural careness. They used design ground motion structure for the structures. In Japan, they have 4,000 years earthquake data. We don't, of course, we had. I started from 182 up to now. I collected 45,000 earthquakes from different sources and different epics and so many literature, Urdu, English, and other languages. I got it. Whatever I got it, I put it in on table and presenting to you, and made the structural, at least spectral acceleration response spectrum should be, elastic response spectrum should be taken, actual spectrum, not hypothetical spectrums. What is the actual spectral accelerations existing on the basement of the structure? If you know the period, you can design your structure for multi-story buildings. In future, all over India, multi-story buildings only the alternate solution for the accommodation of so many people. So it is known population increasing and the accommodation should be increasing. So they have to construct verticals. Verticals, if they are constructing, they have to take the response spectrum values. I have shown you in one of the slides how the different structure heights will affect the natural period of the ground and natural period of the structure. If it is both of them are equal, the collapse of due to big earthquake, the whole building will collapse like Mexico earthquake. That is my ambition.
Thank you, sir. Thank you.
Yeah.
You're on mute.
Thank you, sir. I would like to remind all the participants to please fill the feedback form so that your attendance is ensured. Meanwhile, I would like to inform you all that Sir is nominated for the renowned Padma Shri Award, and Government of India has given us the right to nominate him. The public citizens can also nominate him, so the nomination link will be sent to you. Please nominate him before 15th of September. Thank you, sir, for being a part of our event and gracing us with such an informative and interactive session.
This is my book. Actually, dear students, I would like to show my book, which is my lifetime. This is my lifetime research for Indian continental region. I have collected all the data and put it in one book form. the great persons like Indra Mohan from North India, he came to me. You are the only person to do this type of zoning map of India and collect all the information from different parts of the country and make it as a record of the book for future generation. So I'm very much thankful to him today because my book was sold out. Some books are still there. And if anybody is interested, for students, 50% discount will be given. And my ambition is make Indian infrastructure earthquake resistant. The saline buildings are more in future should be there because the population increasing day by day, and we should have some accommodation. So we should have verticals. That means tri cappers. So the response spectrum, nobody has prepared spectral acceleration maps can be generated by using 3 maps. And if you know that the frequency value, you can understand to construct the without that natural frequency of the ground, you have to construct the design, give the design to the structure, and will be safe. People's safety will be more important for the future generations. Thank you very much for giving me such an opportunity. My dear students, I am very much thankful to you. And this is the first webinar I am giving to you to the Kashi Vishwavidyalaya. I am very much thankful to you again and again.
Thank you, sir. So the whole geoscience community is very grateful to you for your contribution in seismological studies. Thank you very much, sir.
Thank you. Thank you.
Thank you, sir.
Now, I would like to thank all the professors present in the meeting, my dear colleagues, participants, and one and all present here to join us today. It's time to conclude this session. Thanks, everyone.